I'm Anil Kumar, and in this video we are going to learn how to take the key points to sketch a logarithmic function. Now this is a very important question. Once you know how to take the right points, then you can sketch the base function, and from there you can sketch the transformed function. We'll talk about transformed function in the next video. Now here the thing is that let's say we have a function log to the base of x. Now we need key points for this function. Now how to get those key points? That is the issue. Now think about it like this. Let us say we have y equals to log to the base p of x. If you have to write this in exponential form, then how are you going to write it? In exponential form, it becomes x is equals to b to the power of y. Now that is key for getting the critical points for our graph. I will show you how. Now when we say key points, then we are actually interested in x and y values, correct? So what x values and y values should we have so that we have coordinate points which can be plotted and we get a good graph? Now let us consider general function first, and then we will get an idea of how to do it for any function. Any function means, I'll give you examples for, let us say, log to the base 2 of x. We can have log to the base 3 of x. We can have log to the base 5, let's say 10 of x. Any function, right? So I'll give you key points for all those after we discuss this. So x values we are looking for as x equals to b to the power of y. Y values log bx, which we want to fill in here. So the key here is, as you know, I always start with 0. So if I do b to the power of 0, then the y value here is, see, y, right? Y is 0. That means y is log b of x, correct? So y should be this value, 0. Is it okay? If I write 1 there, y value will be 1. If I write 2, y will be 2. How about minus 1? It will be minus 1, and minus 2 will give me minus 2. Do you get the point? So we get the y values from these values, right? Now what are these values? Let's write them down also, right? It is not difficult. Maybe in terms of b, anything to the power of 0 is 1, right? Anything to the power of 1 is the number itself. And this is b square. B square, you know, is b square, correct? Let's write b square. B to the power of minus 1 is 1 over b, and b to the power of minus 2 is 1 over b square. So these are the points, which are the key points. I hope you got it, right? If not, let's take a particular example. Let's take log 2 of x, okay? So log 2 of x, this time I'll give more room. Okay. So we'll put the x points here and the y. Y, when I say y equals to log 2 of x. Got it. Let's begin with 0, right? So 0 means b here is 2. So we'll write 2 to the power of 0, y value is 0. 2 to the power of 1, y is 1. 2 to the power of 2, y is 2. 2 to the power of minus 1, y is minus 1. 2 to the power of minus 2, y is minus 2. Well, but what is 2 to the power of 0? 2 to the power of 0 is 1. 2 to the power of 1 is 2. 2 to the power of 2 is 4. And when I say minus 1, it is 1 over 2. Minus 2 means 1 over 4. Is that fine? Perfect. The points are x and y values, right? So here the x coordinate point is 1 over 4, y is minus 2. X is minus half, y is minus 1. Plus half, y is minus 1. X is 1, 0. 2, 1. And 4, 2. So that is how you get the coordinate points in the form of x and y. Do you get the idea? Now, with this, you can actually do all, right? So it's easy. So let's do for log 3x, right? So this time we'll write straight away. We can, correct? Let's write straight away. We are talking about 3, so anything to the power of 0. So let me write 0 this time here. So I'll write 3 to the power of 0 is 1. Is that okay? Now 1 means 3 to the power of 1 is 3, 2 means 3 to the power of 2 is 9. And if I write minus 1, then I'm saying 1 over 3. Minus 2 means 1 over 9. Isn't that simple? Let's go one more time. This time with base 10. Okay, so if you want to get a 0, then it should be what? It should be 10 to the power of 0. Anything to the power of 0 is 1. This is the very critical point. 10 to the power of 1 is 10. 10 to the power of 2 is 100, right? 10 to the power of minus 1 is 1 over 10. 10 to the power of minus 2 is 1 over 100. So likewise, you can get key points for any logarithmic function, right? So these are your key points. One more key line, I should say, is the vertical asymptote when we're talking about. So the other parameter here is what happens if x is very large, if x is approaching 0, right? Or what happens if y value becomes negatively large? So we say when x is approaching 0, right, approaching 0, that too from the positive side, you cannot approach from the negative side, then y approaches negative infinity. Now this is standard for any log function, right? So you can just remember it. If you can't understand, just remember, okay? So when x approaches 0, y approaches negative infinity, and we say we have a vertical asymptote. Vertical asymptote at x equals to 0. Do you understand? And at that time, y is approaching negative infinity. Perfect. So that is how it is going to be. And now to summarize, let me just give you a graph of a general logarithmic function, right? So it should be something like this, where let us say this is y for us and this is x for us. In that case, the graph of logarithmic function will be kind of like this. Do you see that? And always, as you've seen this point, correct? It doesn't matter what base is. The x-intercept is going to be at 1. And we have a vertical asymptote. That's your vertical asymptote. X equals to 0 is the vertical asymptote, correct? Now, if whatever the base is, if I put, let us say if we are talking about 10, for example, so if x is 10, then the y value is going to be 1. So 1, the value 1 for y, the value 1 for y is corresponds to base of your logarithmic function. And that is how you can actually, from the graph, get the base function or even the equation of the logarithmic function. I appreciate your going through this video, and I hope you learn a lot from here. Share your comments and views, and if there are any questions, let me know. Thank you and all the best.